Welcome and thank you for standing by. Attendees will be in a listen-only mode for the duration of the webinar. This session is being recorded and will be posted publicly. If you have any objections, you may disconnect at this time. Now I'd like to turn the session over to Victoria Howard. Victoria, you may begin.
Great, thanks. Hey everyone, thank you so much for joining us today. My name is Victoria Howard. I'm the Director of AI Policy and Strategy in the Office of the Undersecretary of Economic Affairs here at the Department of Commerce. We will be, and I'll be moderating this panel today on the Department of Commerce's RFI on AI and open government data assets. We're so excited to have you all learn about our work, so let's get started. So first we'll hear from Oliver Wise, who is the Chief Data Officer and the Acting Undersecretary of Economic Affairs here at the Department of Commerce. He'll give a little bit of background on this initiative, why we put out the RFI and the working group leading it. Then we'll hear from Kenneth Haas, who's the Senior Computer Scientist here at the Census Bureau. He'll talk a little bit about the specifics of the RFI, where we are thus far in our understanding of generative AI and open data. And then we'll hear from Sally Ann Keller, who is the Chief Scientist at the US Census Bureau, and she'll talk a bit about the open questions that we have listed within the RFI. We will then open it up to questions, and I will be reading them from the chat. So if you could put your questions in the Q&A portion of the chat or in the general chat, I'll be reading both. If we don't have time at the end for all of the questions, we will be adding an FAQ section to our Commerce website. And if you still have any questions, comments, concerns, feel free to email me at contact@ousca@doc.gov. And with that, Oliver, go right on ahead.
Great. Thank you so much, Victoria, and thank you to all our attendees of this webinar who are listening in today. So as Victoria said, my name is Oliver Wise. I'm the Chief Data Officer and Acting Undersecretary for Economic Affairs here at the Department of Commerce. And I'm here to tell you a bit about what the Department of Commerce is and what we're all about. So who is asking for this information, and to lay out the context in which we are asking this information. As Victoria mentioned, I am the Chief Data Officer and Acting Undersecretary for Economic Affairs here at the Department of Commerce. Within that role, I oversee an office that delivers economic insights to policymakers, drives evidence-based decision-making, maximizes the value of data to promote growth and opportunity for all communities, and strengthens our statistical system through oversight of two of the crown jewels of the statistical system, the BEA and the Census Bureau. But at the Department of Commerce, within my CDO role, we generate a huge amount of data from a wide array of topics, including the weather and climate at NOAA, and economic and demographic statistics at the Census Bureau and BEA. We also generate a significant amount of scientific data at NIST, data about entrepreneurship and patent and trades at USPTO, and a variety of other administrative data through the various offices that we oversee. And in the Department of Commerce, we have a strategic goal to expand opportunity and discovery through data. So we are committed to ensuring that we're using the latest techniques and technologies to create broad dissemination of our data so that all Americans can leverage the insights from this data to promote opportunities within their own lives and and in the communities in which they reside. So if you go to the next slide, I just want to put this RFI in context here. So if you go to the next slide, there's been an awful lot of conversations around generative AI and government, especially since generative AI has really hit the scene in the last 18 months or so. And those questions there's really been two main conversations that are being had. And today with this RFI, we want to introduce a third question as well. So the first question is, how can we promote responsible AI in society? We're not going to deal with that here, but that's a very important question that's being dealt with at NIST, which is a bureau within the Department of Commerce through their risk management framework, and is being instituted in the AI Safety Office, which is just being kicked off. There's also a lot of conversations being had about how we can leverage Gen AI responsibly within government to maximize the benefits of the technologies and also mitigate the risks. And that was indeed very much the subject of President Biden's executive order and the accompanying OMB guidance that followed with that. But that also is not the subject of today's RFI. What is the subject of the RFI is how can government as a major data publisher and producer leverage AI as a force multiplier to democratize access to data. So that's the question that we really want to pose here and the conversation that we want to kick off with this request for information. So if you go to the next slide, I think we all understand that that a new emerging technology has hit the scene and is beginning to affect our economy, our society, our democracy in ways that we're only just beginning to understand. But if you look towards history, and you can see a pattern emerge of how emerging technologies change public expectations of what is possible, and then how policy follows. And indeed, if you look to the history of emerging technology and information and data democratization, we see that pattern very much follow. And I think where we are now with the emergence of generative AI is that the public will expect a natural language interface to accomplish many, indeed, maybe even most tasks. And data analysis is one such task that I think we're seeing users increasingly use these technologies for. So let's just put this in historical context here. So in 1959, you had this emerging technology, the Xerox photocopier, right? And prior to the launch of the photocopier, if you wanted a public record, if you were interested in understanding government records or government data, you literally had to go to a library or a government office and do that analysis on site. And what the emerging technology of a photocopier allowed was for the public to go to a library or government office, make a photocopy, and do that research for home. And that broadly scaled the public's ability to access public information and statistics. And indeed, so you had this emerging technology, public expectations changed about what was the art of the possible. And indeed, about 10 years later, you had the first FOIA laws, which we still have now, which was the policy changes that required government to free up their access to data, because now it was possible for government to do that with making photocopies of their records. Then if you go to the next slide, you have the emergence of the internet and APIs. And indeed, in 2000, Salesforce launched the first API, and that allowed entities of all different kinds to make data far more accessible. And what the government adopted those technologies about 10 years later with the launch of data.gov and the Open Data Executive Order that followed that. And what that innovation was really the embracing of these technologies to create access in a much more broad way to data by and it required the Open Data Executive Order and the laws that followed required governments to publish their data in ways that are machine readable. And that means that so that users could leverage modern business intelligence tools and statistical software to ingest that data and then to use their own know-how and contextual understanding of that data to understand that data. And that was a very exciting movement and really broadened access to data across the country and indeed across the world. And open data really saw a touch point within the pandemic, because there was much greater demand for public health data, and these having data in machine readable formats allowed users to access those data in new and novel ways. And indeed, those new innovations emerged, such as the Johns Hopkins Coronavirus Resource Center, that made use of that open data to provide that data in new and novel ways to users. Now, I think if you go to the next slide, we're at the precipice of an even more profound change in technology that can broaden access to data and level the playing field for users with the emergence of generative AI. So right now, where we find ourselves in is that users, when they try to obtain insights from our data, have to go through a pretty lengthy journey, if you go to the next slide, in order to obtain the insights that they need. So this is a slide from a graduate thesis by Drew Zachary, who's at the Census Bureau. And she found that there are just many off-ramps for a user to get frustrated in trying to find the insights they want by navigating a government website to get the data they need. With the promise of generative AI and the emergence of natural language processing interfaces to get insights on all sorts of things, a user really just needs to have a need for data and then can use a commonly adopted generative AI tool to get access to that data. However, if you go to the next slide, right, so yeah. What we're finding is that we're not off to a great start with these technologies. Clearly, there's a lot of promise to them, but because, and this is an example from an early experiment that we did on two of the common Gen AI applications, ChatGPT and Bard, where we asked those applications to tell us about the demographics of Suitland, Maryland. That's where the census and BA are headquartered. And those bots provided incorrect information to the user. And the reason for that is that those, at the time, those two applications were just drawing on their training set of data to provide answers to their to the prompts, rather than retrieval augmented generation or through other techniques. And also because the authoritative sources for those data, the Census Bureau, our data didn't find its way in a format that those AI could readily understand. So we want to, here at the Department of Commerce, we are committed that we're doing everything in our power so that users don't have an experience like this, that what we had, but instead have an experience where they can use these technologies that are being widely adopted to get insights from our data in ways, and those answers to be reliable, trustworthy, and correct. So if you go to the next slide, please. Our contention is that we're not AI ready until our data is. And what we think we're in is we're in a moment here where we really have to rethink the standards of on how we publish data. And if you go to the next slide, in the open data era that really emerged in the early part of in the aughts and the 2010s, was this construct of machine readable data. That if we published our data in ways that could be automatically processed by a computer and in common formats, users could broaden their access to insights to those data using the most modern technologies available at the time. However, we think we have to move into a new paradigm for how we publish data in ways that are not just machine readable, but machine understandable. And we have some hypotheses of what are those components of machine understandability that Dr. Haas and Dr. Keller will tell you about. But we want to ask you, we want to ask members of the academic community, the industry community, other partners from across different governments who are thinking about this issue of how we publish data in ways that can allow more satisfying user experiences so that we can truly take advantage of these technologies to broaden access to this incredibly powerful data that we have in our publishing. So what we did, let me tell you a bit about what brought us here, is as CDO, I chair our data governance board, and we created a AI and open government data assets working group earlier this year, and that's being chaired by Dr. Keller, who you'll hear from in just a minute. And the goal of that group is to draft guidelines to the rest of our bureaus, who include some of the most prolific data publishers in the world, on how we can make our data more AI friendly. We just launched this request for information to hear from you on how so that we can develop these guidelines with your input, and that RFI will close on July 17th of this year. So we're very excited for this effort and very excited to hear from you on how we can be better data stewards and better data publishers and capture this moment that we're in. So with that, I'll turn over to Dr. Haas.
Hi, I am Ken Haas. Thank you all for coming. I'm going to talk a little bit about the background of how to adapt our data to today's AI systems, and also how today's AI systems need to adapt to the challenges of presenting and using data that we are committed to the integrity of. I'm going to start with a 3-slide history of AI. And the reason for that is because this happens in a context, and understanding AI in general versus just understanding what's happened in the last few years can be important. I'm going to go back to 1961, which was the year I was born, where Jim Slagle, who was a graduate student at MIT, developed a system called SAINT, which stood for Symbolic Automatic Integrator, that was able to solve freshman calculus problems. And this was sort of a huge success. MIT freshmen are pretty smart, and you'd think that since they did that in 1961, by 1965, they would be taking all the engineering jobs. But that wasn't really something that happened. But many people believed that would happen. Part of it is that calculus was particularly easy for computers because A, it was teachable. We had produced it into pieces that people could learn and they could practice. And those pieces were also modular, so they could be assembled. And it was also something that I call polystemic. There are many ways to reach identical results, and the results were actually agreed upon. People didn't argue about what the integral of a particular equation was, but they just were aware of it. So this was 1961, over 60 years ago. Next slide, please. Then from 1960 to 1990, and that includes much of my life and also when I was in graduate school, there was a period that we might have called extended infancy. And one of the things that we learned in that is that many things that are hard for people are easy for computers. There's a story about a ONR administrator, Office of Naval Research, who came to MIT and remarked on the fact that he saw people playing with blocks and he saw people reading children's books, so they thought they might be too hard and things like that. Essentially, people are trying very hard to do things that are easy for people but turn out to be hard for computers. And so if there's sort of one lesson of this 30-year period, the biggest one is that our intuitions about what's hard and what's easy are not very good. And smart researchers struggled for years to get computers to do what 5-year-olds can do. And in that process, he learned a lot about cognition and reasoning, but some of the simplest human behaviors confounded machines. Things like speech recognition or story understanding or walking. Next slide, please. And then between 1990 and now, there was this process that we might call accelerating training. And it took advantage of two things that had happened in those 30 years of extended infancy. Computing power grew enormously, exponentially, following Moore's law. And the amount of digital data that we had available also grew enormously. And part of that was that as more and more of humanity moved online, their conversations, their publications, everything started also moving there. And if you look at sort of the modern large language models, they're training on data that wasn't available online even 10 years ago. And so very large numerical models could be created, trained to use these massive amounts of data. And suddenly problems like speech recognition or simple text understanding or things like that began to fall before these new models. And one of the things is that these models had massive internal complexity, millions or billions of parameters that basically defined complex functions, if you will, that correspond to tasks that people want to do. And that complexity matched or surpassed the complexity of the problems that hadn't been able to be solved before. So next slide, please. We're here. Recently, these generative AI systems powered by the large numeric models have become incredibly fluent in answering questions, generating explanations, and performing a range of creative tasks. I'm often surprised by how much they can do and a little bit worried by how much they can do things that I was proud of myself for being able to do. But on the other hand, they struggle with hallucinations, biases, factual errors, and outright fabrications, which are factual errors that are misleading. But this is not really surprising because the training of LLMs is about fluency and flexibility, not facts or precision. When the machine learns, it's actually learning about language. It's not learning about facts about the world. And so when those LLMs that we tried out in those slides that Oliver was presenting answered questions about census data, what they were doing was some of the census data had particular facts that it used to understand the language that those facts were written in. But the very process of understanding that meant that they had to generalize it, which meant that they had to ignore details. Next slide, please. So what we're looking at as a way to solve some of these things, at least in the immediate term, is a model where you have a question that goes into an LLM. What it produces is a query that goes to a data service or a database that returns a structured response, and then the LLM turns that structured response back into a well-composed answer. And the thing there is that we're actually accessing an authoritative and relatively unambiguous data service in order to get the answer. And so that can address a lot of those issues. Now, this is something that folks in the LLM world sometimes refer to as RAG, Retrieval Augmented Generation, that we're looking at how to do. But one of the things here is that we need to do two things on the two sides of it. Usually when someone's using an API, they know a lot about the domain that they're querying about. And that's knowledge that isn't sort of common sense that an LLM could necessarily get by reading all of Wikipedia and a bunch of other things. And so it involves evolving both the LLM and the API. And that's one of the things we're looking forward to that. And part of the RFI is to ask for input on ways we might do that or things that might simplify it. Next slide, please. And so the idea of machine understandable data is things that can be used to guide the use, combination, and explanation of data in what I call responsible ways. The Census Bureau, for instance, is very concerned about data integrity and statistical standards. Many, if not all of our surveys come with margins of error, where we say, we've done this, but it's a process where we did a survey and there are processes of incompleteness in the survey. And so machine understandable data is making a lot of those things explicit. Next slide, please. So part of the idea here is that we want to have knowledge graphs that describe the variable level metadata so that we can basically link human terms to those data elements. If you've looked at any of the data that's in the census databases, the names of the variables, the columns are pretty cryptic, like SS34 or SS01. And we need to have some kind of better annotation in order to make those connect to any LLM. As part of that, and in order to make it easier, we can embrace standardized ontologies like schema.org or NEEM or other ones that are out there. And also by harmonizing and linking our internal ontologies and vocabularies using those knowledge graphs as a grounding. Next slide, please. Part of what we're going to be doing internally as part of this is gathering internal and external written documentation of the existing data products, and also adopting data formats which allow for rich metadata or for generating metadata sidecars for things like CSV, which don't allow embedding very easily, as a better way to represent our data. And we're in the middle of a huge transition to the cloud now, and we're looking at updating our data formats and data standards with respect to that. Next slide, please. And part of this is also looking at our APIs and using the open standards that are out there for describing APIs and linking those into knowledge graphs and having those knowledge graphs linked into ontologies which are out there. And one of the important things is that the fact that there are multiple ontologies is actually a good thing, because in linking those ontologies to one another, we can actually learn important ways that things are different. Just because things are different doesn't mean that one's right or one's wrong. There are all attempts to describe things for particular purposes, but the purposes may be different. And finally, improving the guidance and metadata around data usage and licensing for things like research analytics, data mining, and AI ingestion. Next slide, please. So that's the summary. I'm sorry if I talked a little quickly. I'm from MIT. You have to do that to get a word in edgewise, and I'll be happy to take questions or clarify things or anything like that. Thank you, and I'll pass it on to Sally.
Hello, everybody, and thank you for joining us today. I'm delighted to be here with my colleagues to share with you the Department of Commerce's thinking around AI and open government data assets. What I'm going to do is to just quickly walk through the parts of the RFI. We have 5 different sections in the RFI where we're asking for your input. And so let me just quickly walk through those, and then we'll turn over to your questions. So next slide, please. The first area that we're asking for your input is around data dissemination standards. So rather than telling you what standards we will use, we're at that early stage where we're really asking for your input on what dissemination standards might be useful for the Department of Commerce to adopt to support the human readable and machine understandable public data. You may recall that Oliver made a comment and had a slide on just the diversity and breadth of open data, public data that the department produces, everything from climate to derived data around population counts in the decennial census, and a lot of things in between. Data that comes in on sensors, data that comes in through surveys, data that comes in through administrative records. And so we're very interested in how do we handle all of these sorts of data sources that we put together to create our public data. What are the formats, the metadata, what documentation do we need to facilitate what we're doing? And is it different depending on the data source and the type of data? We're also interested in understanding about licensing practices and standards that might be considered, and that what current standards exist or are under development that we should be aware of that might help us as we take this journey. Next slide, please. The second area for your input is on data accessibility and retrieval. That's really what this is all about. How do we make our data accessible and easy to retrieve? And in particular, such that it's valuable to the AI community. And again, remember that we are trying to make our data ready to be ingested into the large language models that can just describe the questions that come in and the solutions that come out. So how can we develop intuitive and accessible data portals that are going to facilitate the navigation and retrieval? How do we, disseminate the AI-ready data just generally? What measures should we consider to help encourage user-friendly interfaces be developed, including labeling and readable formats? And how can Commerce better understand the needs of the users for its data and the return on the investment that we will make in making our data more accessible to generative AI? Next slide, please. The third area is about partnerships. We're really interested in partnerships with industry and academic stakeholders. How do we collaborate with you, and how do you collaborate with government to shape the design and dissemination of AI-ready open data? One of the reasons this RFI, this request for information, is so important and timely is because, as Victoria, Oliver, and Ken all said, we're at the early stages of developing guidelines and best practices for the department. And you can really help shape those and help shape the types of collaborations that we should be making that can really leverage the best of what you know with the best of what we know. Next slide, please. The fourth area is on data integrity and quality. This is just incredibly important for the department. And we need to understand what are the best practices that industry has employed to ensure integrity and accuracy of public data. Perhaps industry is doing this for proprietary data, but we would like to know which of those things might be applicable for us here. It's really critical that if there is a user, a stakeholder, that poses some sort of a question that filters through a large language model, goes out and grabs the data and filters the response back through a large language model, as Ken showed on his particular hybrid slide, that there be some assurance that that data is actually coming from us, or if it's not coming from us, that it's clear that it's not coming from us. So how do we ensure the integrity and quality? And the things like authenticity bias, privacy, equity, and ethical use to maintain transparency and accountability. What are the security protocols that we need to be developing to mitigate risk of having our data manipulated in some way? Next slide. A few more questions on data integrity and quality. As transparency is very important to us to ensure that the data sourcing and processing methods will engender trust and are reliable. We're very interested in understanding validation processes that could be established to maintain and verify data accuracy and consistency. And how do we facilitate comprehensive and transparent data documentation for replication and analysis? Again, this whole transparency, trust, integrity, quality is just central to the guidelines and the best practices that we will be developing. And then the last area, next slide, is for data ethics. What steps do we need to establish clear legal and ethical guidelines for AI data usage that ensures privacy rights, preserving property rights, and focusing on equitable outcomes? Again, I can't underscore the breadth of data that the Department of Commerce covers, the breadth of activities that we cover. So all of these things are critically important for all of our bureaus, not just the Census Bureau. Then what types of policies should we be implementing to identify and mitigate biases in AI algorithms? There's a lot of guidance that's coming out about responsible AI. How does that map into what we need to be doing? What are the best protocols for ethical data collection, processing, and storage that prioritize integrity and accuracy, which are two of the most important things that we can produce and put out for the public? And one thing that I did skip over on one of the earlier slides is we're also really interested in your thoughts about sort of the space of data users, going from the very novice, maybe atypical user to, that high-end researcher. There's that whole spectrum that our data dissemination, our statistical product dissemination serves. Are there nuances there that we need to be paying attention to as we move across that spectrum? And with that, I just really want to encourage you to respond to the RFI. You don't have to respond to all parts or all questions, just simply respond to those pieces where you feel that you have some valuable input that we can take advantage of, and valuable input to guide us. And so with that, Victoria, back over to you for Q&A.
Thank you so much, Sally, and thank you also to Ken and Oliver. As Sally mentioned, we'll go into the Q&A portion of the webinar. So we have 3 core questions, and I will first kick off this one to Tyler Christensen, who's joining us from NOAA, who's been leading a lot of the AI Ready initiatives within her bureau. So the first question we had that was offline was, how do you see the role of data cards in your open data initiative?
Yeah, that's a great question. So the data cards it's one of several ways of documenting the data set, a data set that's being used to train an AI or machine learning model. So it's a way of basically showing your work, disclosing the sources of data and the quality and provenance of those data sets as a way of increasing the transparency and the trustability of your machine learning model. So, but it's about the training data for those things like the data cards. So this is what we're talking about here is a little bit different. It's not so much about training the large language models. It's about providing data access points where the already trained LLMs can go to get factual data from government sources. But there are definitely some concepts in there that we could include in our documentation. So things like provenance, intended uses was another one that was in the data cards, and then so there are some concepts that we can take from those ways of documenting training data sets that we could also provide for these API access. So that's a good suggestion.
Yeah, and someone in the chat said nutrition facts for LLMs. So the next question we had was, someone gave the example of Census GPT, and their question is, have there been other prototypes or considerations to partner with, like basically other people who've been developing systems such as these? I don't know if Oliver, if you're still on, do you want to talk about Google Data Commons and other initiatives that have been being built on our data?
Yeah, sure. I think there's a number of emerging experiments in this space that are very exciting and we want to learn more about. as Victoria just mentioned, there's Google has the public data commons project where they've ingested large amounts of public data from across the world, including some of our own data, normalize that data to a standard schema, schema.org, and then put a Gen AI or a natural language processing interface on top of that. That's in production, and you could find that fairly easily. There have also been examples that we're beginning to see, such as an example from the IMF, where they've tuned a foundational model to translate natural language queries, prompts rather, to formal language queries, so that users can better obtain statistical information from their website. From their website. And we know of other statistical offices in some European countries that are experimenting with the same. So I think there are emerging experiments in this space. I don't think anyone's like cracked the nut on the perfect way to do this, but we are encouraged and want to learn more about how people are trying to solve this problem and what we can do as data publishers to unblock further innovations.
Thanks, Oliver. Our next question is, what assumptions are you making about data sensitivity related to making it accessible? Are there any assumptions we should make in our response related to sensitive data being included in this initiative?
I'm happy to, oh, sorry, Oliver.
Yeah, go ahead, Sally. Go ahead.
Yeah, I was going to say that I'm happy to field that one. So all of our typical data protection and confidentiality requirements and standards hold. So we are talking about open data. We're not talking about confidential or sensitive data. So anything that would be possibly available for a large language model to ingest or even train on would be data that has already gone through all of our confidentiality filters.
Great, thanks, Sally. And we had another question that was already kind of addressed by the group. Will Department of Commerce provide us data to train our large language models? I don't know if anyone wants to just retouch on the fact that how different organizations are already kind of grabbing our data to build these models.
Yeah, so there are existing streams of work, and maybe Tyler can answer this question. Like NOAA opens much of its environmental data for researchers to develop their own models. Our public data can be used for all sorts of purposes. So you can go at it for developing your own models with our data. But really what we're concerned about here is not training new models or even fine-tuning new models, but ensuring that our data is prepared and published in such a way so that lay users of off-the-shelf Gen AI technologies like ChatGPT, but not limited to it, can leverage those widely adopted tools to analyze and understand and interrogate our data, and do so with the expectation that they're going to get correct information from the most recent sources. Tyler, do you want to add anything else just on NOAA's existing work on opening data for training AI models?
Yeah, if we're talking about the broader AI and machine learning, broader than just large language models, then yes, NOAA does have efforts underway and data sets already available that are labeled training data sets that are meant to be for training AI machine learning models. But that's more about numerical weather prediction and things that are much more specialized and for hard for expert data users. And so what we're talking about here is really a different effort, which is about democratizing our data access by making it available via large language models. So it's really a different question. Yep.
I think another thing to say here is that the training is really a lot of the data that we're talking about, especially from the Census Bureau at least, and also NOAA, are it's structured numerical data. And usually training is a process that is essentially trying to discover how to extract structure from unstructured data. And so there's not much to be gained by taking a bunch of structured data and pulling out the structure, which everybody already knows is there.
Amazing. We don't have any more questions. Before we hop off, does anyone else have any other points they want to add or throw in for our audience?
I just want to underscore again, we've put out in the RFI an incredible rich set of questions, and we really do need your input. And so if you could share the RFI and the information about it with your colleagues, you know, in industry, academia, private sector, other private sector areas, government, and just encourage people, you know, even if it's a short response, just, you know, send us some input and guidance, point us to things that we should be considering and looking at.
Yes, and if you have any questions, again, please email us at contactousea@doc.gov. Perfect. All right, well, thanks everyone.
Thank you.
Thank you.